All right, here we are in lesson 14, video 2, and we are ready for part B in your book, looking at rectangles, vertices, and all of those things. Okay, in the coordinate plane for part B, plot any 2 points in the coordinate plane that lie on the same vertical line. Okay, so remember vertical is up and down, so we're looking for any 2 points on the same vertical line. I'm going to pick 5, 3 and 5, 10. Okay, you pick whichever 2 you want. Free choice, point picking. All right, and once you have those done, you're going to trade papers with your partner. Your partner also plotted 2 vertices of a rectangle, and you're going to determine the locations of the other 2 vertices. Plot those points, draw the rectangle, and then write your ordered pairs next to those vertices. Okay? So go ahead and do that now. Think about how you're going to draw the rest of your rectangle. And something I forgot on the last one is to put the ordered pairs. Okay, get that done. How is your thinking when you are given vertices that are on the same vertical line different from your thinking when you're given opposite vertices like we had here? You had to think of how big you wanted your rectangle to be, right? We didn't have a parameter for that. So you could have chosen any line, and it could have even been on this side, to make your rectangle. So your rectangle probably doesn't look like mine, unless you copied me. How many possible rectangles can you create when given 2 vertices on the same vertical line? An infinite number of rectangles. Could have been to the left, could have been to the right, could have been as wide. And you might be saying, well, no, it could only be, as many as lines we have, but we could have part of a line, right? We could have 7 1/10, 7 2/10. So we could make a lot of different rectangles, even down to the hundredths, the thousandths. Yeah? Okay, so we could make a lot of different rectangles. Okay, let's go to part C. Part C in your book, another coordinate plane, and this time in the coordinate plane for part C, plot any 2 points in the coordinate plane that lie on the same horizontal line. Then write any number between 1 to 5 on the line provided. Okay, so you're going to put 2 points and then write the number on a horizontal line. So I'm going to pick 210, and we're going to put our ordered pairs and 1010 on our horizontal line, and then we have to put a number between 1 and 5. So I'm going to say 2. Okay, you can put your number, whatever number you want, and when you finish, trade papers with your partner. And your partner also plotted 2 vertices of a rectangle, and the number that your partner chose represents the height of the rectangle. So you have to determine the locations of the other 2 vertices. So since I have a 2, that means that mine's going to be 2. So I'm going to put it right there. And we have to put our ordered pairs. So that would be 2, 8 and 10, 8. All right, and draw your rectangle. Very good. In part C, you were given the length of the vertical sides, right? This was the number that you chose. How did those measures determine the number of rectangles you could draw? You could draw one coming down this way, or you could draw one going up that way, right? So there was only 2 possibilities. Or, depending on how close you were to the edge, maybe you could only draw one, right? Okay, excellent. Let's go to D. I know, it is kind of fun. Geometry, it's a little bit different, right? In D, our problem is the segment shown is one side of a rectangle. Okay, so we already have one side of a rectangle. Circle the ordered pair for any point that could be a vertex of the rectangle, and a vertex is a corner. So circle any of these that could be a vertex of the rectangle. I'm waiting for you to do it. You're doing it, right? Okay. Let's get another color and look at these possible vertices. I'm going to get pink. Okay, so 8-2. 8-2, could this be a vertex? Yes. What about 2-8? 2-8. Oops. 2-8. Did I draw my line correctly? 7. 6-2 to 6-7. So could 2-8? I don't think that would work. How about 1-2? 1-2? Could be a corner if I drew it this way. Okay. 1-7? Yes. Could be a corner if I drew it that way. 3.5, 2. 3.5, 2? Yep. Could be a corner if I drew it this way. 8-7. Noticing the 7s and the 2s. Yeah, on the 2s and on the 7s. Seems to be a theme there. 15-2. 15, 10, 11, 12, 13, 14, 15, 2. It would be on the 2, so yeah, it could be. 0-7. On the 7. 2-0. 2-0. Oh, down here? I don't think so. 12 and 1/10, 7. 12 and 1/10, 7. Okay. So I think it's all of those. At first I thought it was all of them, but then when I went to plot 2-8, I see that it wouldn't be a right angle if I was at 2-8. And the same thing with 2-0, right? This would not be a right angle. That would not make a rectangle. Okay? So all the ones that are correct have a 2 or a 7 as their Y. Yeah, so that they're on this line. 2 and 7. Yes? Okay. One more to go. Part E. A rectangle with the length of 5 units and the width of 3 units has one vertex 4-4 shown. Okay? Sorry, some of my other colors bled through, so I'm going to make it pink. 4-4 is right there. And I need a rectangle that's a length of 5 and a width of 3. Could you draw it? A length of 5. 1, 2, 3, 4, 5. And a width of 3. 1, 2, 3. Does yours have to look exactly like mine? No. There's a lot of different possibilities, right? You could look at your partner and see what they have. How many different rectangles with the length of 5 units and the width of 3 units could be drawn if 4-4 was not one of them? If you didn't have to have 4-4. It would be infinite, right? So many possibilities. All right. Well, thanks so much for watching. I really appreciate you. And this was only the second video, right? So only 2 videos in lesson 14. Great work. Keep up the hard work. Aloha.